In this video, I'm going to talk about 2's complement and how we use it to represent signed numbers in binary. And before this, we talked about adders and how adders as a data path component can be used to add two binary numbers. We use that for unsigned binary numbers. Taking it one step further to signed binary numbers, we needed some system to come up with a way of identifying the sign, whether a positive or negative number. And that is done in 2's complement by dedicating the leftmost bit for the sign bit, a 0 representing a positive and a 1 representing a negative. So there are several examples in this section of your book that show you how to subtract numbers, right? So you have a positive 5 minus a positive 3. Well, if you make the 3 a negative number and add the 2 together, you're using the adder data path component. So the hardware is easier to build. Now you just need a way for representing a negative 3. So the way to represent a negative 3 is via 2's complement. 2's complement is accomplished by inverting each of the bits for the negative number. So you would get 1100 in this case, and then add 1. So you get 1101. Now take that negative number and add it to positive 5, and there's your answer. We ignore the carry in this case. And so notice what you've done. You've added a positive number, there's a 0 there, with a negative number, a 1 there, and you've ended up with a positive number. That works out just fine. But there is a situation where you may end up with overflow. Overflow being the number's too large to fit in the 4 bits allocated. And so this is explained a bit here, but I wanted to show you some examples that we did in class. Okay, so let's take a look at a couple of things. This one here, 6 minus 3, right? We know the answer is 3, and let's see if that's what we come up with. So the 6 is a positive number, so that stays the same. It's represented by 0, 1, 1, 0, correct? Right? This is 4 plus 2. The 3, we know 3 is 0, 0, 1, 1. But this is a positive number. I know that because the 0 in the leftmost bit is positive. So we have to apply 2's complement to come up with the negative 3. So to do that, invert your bits. So you have 1, 1, 0, 0, and add 1. I know my hand is in your way. Okay, and so what do we get here? So 6 stays the same. 0, 1, 1, 0 stays the same. 3 is 1, 1, 0, 1. Now you can add these two together, right? So now you're adding 6 to negative 3. So this is 1, 1, 1 plus 1 is 0, carry 1, and 1 plus 1 is 0, carry 1. We ignore the carry in this case, and we're left with a positive 3, which is the answer here. That is correct. That one's straightforward and pretty easy to see. Now try 7 plus 7. So 7 as a positive number, 0, 1, 1, 1. Right? That's 4 plus 2 plus 1. 0 indicates the sign is positive. 7 is the same here, 0, 1, 1, 1. Okay, now add the two numbers together. Can we do this? So it's 1 plus 1 is 0, carry 1. 1 plus 1 plus 1 is 1, carry 1. 1 plus 1 plus 1 is 1, carry the 1. Right? You're not carrying anything out. So there's two ways to detect that this is a problem. Number one, you've just added two positive numbers and ended up with a negative number. That can't be. Right? So that's bad. The second way to determine that an overflow has occurred is that your carry in to this leftmost bit was a 1, but your carry out is a 0, right? You're not carrying anything out. So when your carry in to the leftmost bit and your carry out differ, that is an overflow. So this has caused an overflow. All right, I'm going to go through one more example here, and then we'll go look at our chart to see how this works and what we know. So 7 minus 7. So this is completely different. Right? So 7, again, is 0, 1, 1, 0, 1, 1, 1. Negative 7 is going to be 0, 1, 1, 1, applying the 2's complement. So it's 1, 0, 0, 0 plus 1. Okay, so here we are again, 0, 1, 1, 1, added to 1, 0, 0, 1. So add these together, 1 plus 1, 0, carry the 1, 0, carry the 1, 0, carry the 1, 0, carry the 1, right? And now your answer is 0. You ignore the carry. This is correct. No overflow. And again, did it pass the test? Right? So you have a positive number added to a negative number, resulting in a positive, which is fine. You have a carry in of 1 and a carry out of 1. That is also good. So in that case, there's no overflow. Now, one more example of an overflow here is 10 minus 9. And why does this end up in overflow, right? It looks like it should be fine. But a 10, if we were to represent this in binary, is 1, 0, 1, 0. And immediately, before I go any further, I can tell this is bad because this should be a negative number, right? It should be negative. Now, if I applied 2's complement to this to figure out what number it actually is, it would be 0, 1, 0, 1 plus 1, which is equal to 0, 1, 1, 0. That tells me that this is a negative 6. So why did I apply 2's complement here and not in some other cases? Because this started with a negative sign. Right? So immediately I could tell I've got a problem going on here. Now, how do I know that here? So come over to the chart that is in Blackboard that we did together. We did the 3-bit chart. We did the 4-bit chart. This is the 4-bit. And what you know by looking at the 4-bit chart is that with 4 bits, you can possibly represent 0 through 7 positive, negative 8 to negative 1 negative. Right, so look for your patterns. This is what I'm telling you, is always look for your patterns, and you'll be able to know if you have overflow without even trying. So the patterns are this. The leftmost bit being a 1, everything else being zeros, that is the largest, I said it wrong, the smallest negative number. Right, so if you had an 8-bit number, it would be 1, 0, 0, 0, 0, 0, 0, 0. What number is that? That is 128. So this represents negative 128. The other pattern to look for then is this. Right? This is going to be your largest positive number. Largest positive number, the first bit is a 0. All following subsequent bits are 1s. So in an 8-bit number, it's 0, 1, 1, 1, 1, 1, 1, 1, which is 1 less than the absolute value of this, which is 127. So now if you try to add 2 numbers and your result is greater than 127, right? Overflow. If you try to subtract 2 numbers and the number is smaller than negative 128, overflow. So without even going through the process of trying to perform addition or subtraction, you'll know just by virtue of understanding the pattern here whether or not you'll have an overflow condition.